So now I just want to do one example today of how we answer the questions with the similar triangles theorem. So quick reminder of our theorem. If I have a triangle XYZ that is similar to a triangle ABC, then their sides are in proportion in order, meaning that XY divided by AB is the same as XZ divided by AC, which is the same as YZ divided by BC. Okay, so let's look at an example with this and how we'll use it. We've got a diagram with two triangles that look to be similar. The first one looks like this. Have an angle marked in here. We have a second angle marked in here, marked differently. X is the length of this side, and 6 is the length of this side. And we have another triangle. And suppose it was rotated like this. But I still have these marked in like this. Now all three angles aren't marked. So the first question asks us to explain why the two triangles are similar. And they'll be similar if all three of their angles are equal. So we know that in any triangle, the angles add up to 180 degrees. Therefore, if two angles are the same, and they are because we were told that by the diagram, the third angle must also be the same. And therefore, our triangles are similar. So long as what you've written down is clear, you don't have to use full sentences, and you can use symbols to represent triangles, squares, etc. So the second question then asks us to find the length of the side marked X. So find the length of the side marked X. So we're also told that this is 4 and this is 5. We need that information. Find the length of the side marked X. Okay, well, if we're going to use our theorem, we need to mark in our corresponding sides, so which sides match. Let's start with this one here, the side that joins the two angles together, the two given angles. So those sides must be corresponding. They must have the same length. And also this long side here, from the unmarked angle to the angle marked with 2 dots, must have the same length as the corresponding side over here. So we've marked in our corresponding sides, and that means that one corresponding side over the other one is the same in both cases. So from our theorem, we can say that x over 5 is equal to 6 over 4. I can go the other way as well. I can say 5 over x is equal to 4 over 6. I'll get the same answer. The important thing is to go the same way both times. So let's solve this, which we can do by cross multiplying, and we get 4x is equal to 30, and x is 30 divided by 4, or 7.5. We weren't given any units, so we don't need to write them in. And that's it. Okay, the next topic in geometry is circle theorems, but before we move on to that, I want you guys to do a lot more practice with the types of questions that come up from these. It's all the same kind of thing, but I'd like you to spend the rest of today practicing with the homework, and we'll go through the solutions on Monday and possibly the solutions to the test as well. So we may not be moving on to anything new on Monday, just going over what we've already learned. Okay, thank you.